Okay, so 5-7, application and models. Okay, so here we have a right triangle, triangle ABC, okay? We know that angle A is 34.2 degrees. We know that this is a 90-degree angle. We know that side B is 19.4. It wants us to solve for all the unknowns. That would be angle B, side C, and side A. How can I do that?
Well, you can find B by adding 90 and 34.
Good, so I can find angle B easy, so let's do that first. So what is 90 and 34 added together?
9, 10, 11, 1, 12, 102 point something.
What?
124.2.
124.2. And what do I have to do with that?
Subtracted by 180.
180 minus that. So what's 180 minus 124.2?
66 point.
No, 55.8.
66.
Yeah.
55.8.
It's okay, Talia. You ain't know how to do math.
I'm not good.
That is angle B, yes? This green marker is really green. Okay, so that's the first thing I need to find. How can I find side A and side C?
Pythagorean.
So Katoa.
Nope, not Pythagorean. We don't have enough information. You would need two sides to do Pythagorean theorem.
Find one of the other
Sit down,
sides.
Winston.
Use tangents.
Yes, use stuff like that. Use sine, cosine, or tangent.
Talking about Alex. He said.
So let's look through angle A. If I want to find side A, what am I going to do?
Opposite.
Opposite over adjacent, which is what?
19.
No. What is opposite over adjacent? Am I using sine, cosine, or tangent?
And.
Tangent. A equals opposite over, right? Okay. So I'm going to say tangent of 34.2, right? Equals A over 19.4. So 19.4 tangent 34.2 will give me A. What does that come out to be? Round to one decimal place. What's it come out to be? Someone's going to tell me because I'm not telling you.
That's wild.
Let me write the problem down first, guys.
I got your father on calculator.
Yeah.
34.2. Negative 7.
I'll take
Guys, focus and answer. Let's go. You should have a calculator out. Everyone should be doing this. Because here's the deal. You don't know how to do it on your test and quiz because you don't practice it in class.
All you do.
You might want to make
Negative 14.
Nope, Talia, you're probably in the wrong mode.
Someone's at the door.
Because you're trying to
What is it?
13.2.
13.2. So side A is 13.2.
13.0.
Thank you, Carrie. Okay, now what do I have to find? What else do I have to find? What's the other thing I have to find?
The C.
Side C. And what proportion or what am I going to use for that one?
Pythagorean theorem.
Actually, here's the deal. I don't want to use Pythagorean theorem on into this because I want to get more of an accurate answer. So we're going to use sine, cosine, and tangent every time. Because I want the most accurate answer we can get. So, are you going to use sine, cosine, or tangent to find C over B? What is C?
C's the.
Hypotenuse, and B is my
Cosine.
cosine, because it's adjacent and hypotenuse. So you're going to say cosine 34.2 equals my adjacent over my hypotenuse, yes? So these two switch places. C equals 19.4 over cosine of 34.2.
Whoa, why'd you switch?
Because you would have multiplied by C to get that from the bottom, and then you would divide by cosine to get it back over there.
Words can't
20, 30 points.
You get 23.5?
Yes.
Okay. And now I've solved for all the unknowns. So you're going to have problems like that tonight where they give you one or two things of each and you have to solve for everything that's missing. Okay? That should be the easiest part. Then we come to word problems. Okay,
We're probably gonna do
word problems, you're gonna need to draw pictures tonight if you wanna do them right.
Oh, I like
it. I
drawing.
can draw.
Physics.
No
Okay.
one cares.
A safety
Okay,
regulation
both of y'all about to
states,
get it.
stop, a safety regulation states that a maximum angle of elevation for a rescue ladder is 72 degrees, okay? And it says a fire department's longest ladder is 110 feet. What is the maximum safe rescue height?
Draw the picture.
Okay, so this is the building I'm trying to rescue someone out of, yes?
Uh-huh.
Okay, my ladder has a length of how much?
110.
110. And what can my degree be right here?
72.
72. So what am I trying to find?
That's that third one. She's like, what's that? I'll bring up zero.
I'm trying to, no, not the
Oh.
figure
No, the
here.
other angle.
Dang, I felt like Jimmy.
Not
was
trying
wrong for a
to-
second.
I'm not trying to find another angle. I'm trying to figure out how high of a building can I rescue someone out of? So you're trying to figure out
Oh,
what
the
this is
hypotenuse.
right here.
How do you
No,
do
you
that?
have the
I'm trying to
hypotenuse.
find out.
How
I
do
mean,
you
that's
do
what
that?
I meant, the opposite, adjacent, whatever it's called.
Adjacent is at the bottom, opposite is on the opposite side.
Yeah, I'm sorry.
Okay, so we're trying to find out how high this building can be, yes?
Yeah.
Okay, so what do I set up, sine, cosine, or tangent?
Cosine.
Sign.
Sine, you need
Sine.
opposite
somebody
over
Adjacent.
hypotenuse.
I mean,
Sine, 72 degrees equals opposite over hypotenuse, yes? So 110 sine 72 gives me what? Round to one decimal place. Gives you what?
Do we have to put
Are
the
you in
degree sign
degree mode and not radian mode?
Hey, why can't I find that line?
What'd you say?
104.6.
104.6. So you can rescue someone out of a building that is 104.6
I can
feet
do whatever
tall.
the heck I want. They can't tell me what they can tell me.
Degree.
This ain't even mine.
Yeah, is it in degree mode when you're solving these?
Yeah, I don't know.
What?
Okay, so guys, stop. To rescue someone safely, the building cannot be taller than 104.6 feet.
Oh, so
Says
just-
you.
Or it can be
Okay.
105 feet and you can jump it.
Miss Peters, I got a legitimate question. It's like very legitimate.
Well, okay, Tyler.
So, what was I about to ask? Oh, yeah. So then what is, yeah, never mind, I in the book. I got it.
What is wrong with you?
Yes,
Will you approve my pass?
No.
Ain't nothing wrong with me.
Seriously?
Lost
in the middle of
seriously?
I'm amazed. Cora, shut up.
For real.
Okay, so the next problem we're gonna talk about is a little bit more complicated. Okay, it says at a point 200 feet from the base of a building, okay? At a point 200 feet from the base of a building, so if I have this building, and I have a point 200 feet from it, okay? At a point 200 feet from the base of a building, the angle of elevation from the bottom of a smokestack is 35 degrees, and the angle of elevation to the top is 53 degrees. Okay,
Alright,
so we gotta figure out what that means.
Okay, alright,
So
okay.
if my smokestack's up here, right? The
Alright.
angle of elevation from the bottom of a smokestack is 35 degrees. What does that look like?
You got the 90 degrees right there.
Yeah, right here, you
Yeah,
mean?
and then you got the 35 is, at the corner.
Right there.
The
Yeah.
35 is what part though?
Can I, yeah, the top, no, it's the bottom.
It's the bottom.
Yeah, it's the bottom.
Alright.
So
From
like
the
it's-
bottom of the,
Yeah,
Smokestack, so it's
so
on
from
top.
here to
Yeah.
here, it is,
35 degrees.
okay? And the angle of elevation to the top of this is
No, that just don't make no sense.
53 degrees.
Why is it a rainbow?
Yeah, it says elevation from the bottom of a
Oh, I
smokestack.
get it.
Stack, the bottom of the smokestack is there, that's 35 degrees.
And then the top
To the
is
top of it is
53.
53, okay? So you got those fitting into each other, does that, do you see that?
I think the first
Find the height S of the smokestack. So it just wants the height of this.
Oh, so we need to find the opposite. I mean the height adjacent.
What's
Tangent.
53 minus 35?
Tangent. Or tangent.
You said tangent?
Yes.
Okay, tangent of what though?
What you do 181?
Yeah, that. I'm using my lifeline.
Wait.
No.
First we can find the angle of it. Cause you can do 53 plus 90 and then the.
No, you don't need to find another angle,
I stepped on my grandma's.
okay? What I do need to find is this, watch this. If I can find the height, right, of this part right here, of that building, okay? I can subtract it from the overall height to figure out what this is eventually. Yes? So find the height of this, the height of the overall part, and then subtract them, okay? Because my angle of elevation from here to here is 35 degrees, yes? Okay, so when I'm working with this triangle, I can find this height and then eventually subtract it because I'm gonna use 35 in this case. And it is tangent. So tangent 35 degrees equals x over 200.
Whoa, 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 whoa.
Opposite over adjacent, yes?
Why would you use 35?
Because Talia, I've gotta focus on this first triangle here.
Oh,
And it's only 35 from here to here, yes? This angle of elevation on this triangle is 35 degrees.
oh.
So I use 35 for finding this length. Okay? So if I find that length, then I can do some stuff from there. So let's do tangent, or 200 tangent 35 degrees, and you'll get what x is. So 200,
140. Yes, sir, Layton.
yep.
Yeah, well, like,
I love that cut.
So I get 140, okay, get 140. Now, for the larger triangle, you have to do,
53.
yes, tangent 53, but I have to add this and this together, correct?
How do you know what the height is for that thing?
The height, well, that's what we're gonna get to, that's how we're solving it. So I'm gonna use this larger triangle like you said, okay?
That's wild.
And I'm gonna say tangent
Oh, I subtract it.
53 degrees equals s plus x over 200, yes?
Mm-hmm.
Okay? Which is why we found this first, because then I can subtract x from it and figure out what s is eventually. Okay? So then, so then I need to figure out what 200 tangent 53 is.
Can I take a picture of this when you're done?
Yeah, you can take a
Thank
picture
you.
of this one. Then.
Brother.
What'd you say?
265.4.
265.4.
That boy laying on a point.
Good.
Yes, Lord.
265.4 equals the s plus x, yes? So what do we have to do to find the height of just the smokestack?
Subtract.
Subtract what?
265 minus 140.
Yep, 265 minus 140.
Hey, this is advanced math right here, homie.
125.4. So the smokestack is 125.4 feet.
What are they burning?
Oh my gosh,
You
maybe
can't
that
say
was gonna
that.
come out of
You
someone's
can't
mouth.
say that yet, Talia. Hasn't been long enough.
Okay, so that is, you might have to do more than one step and more than one process, which is why you need to draw these things out. Okay, if you don't draw them out, I guarantee you're not going to do the math right.
these triangles are really ugly.
I have to draw things out, I can't figure it out. Now we're gonna talk about the angle of depression.
Oh,
wow.
I can tell you that one.
Wow.
It is a 0-degree angle.
Okay.
It's 100%.
This is elevation, which means I'm looking up, so what does depression mean I'm doing?
Going down, which means depression.
Okay, so a swimming pool is 20 meters long and 12 meters wide, okay? 20 meters long, 12 meters wide, got it? So I have a swimming pool that is 20 meters long, and it is 12 meters wide, yes, okay? The bottom of the pool is slanted so that the water depth is 1.3 meters. So the deepest part is 1.3 meters, does that make sense?
Mm-hmm.
So look, you have this going on, it's
You
slants.
draw the water
Oh,
to make it more
gosh.
realistic.
You mean
Only
like
1
this?
meter?
The water's green?
Yeah, thank you.
That's not it.
That's sewer water.
Yeah.
It's got algae in it, algae.
It's not high water.
The Ohio River is basically
Just
just.
take
Okay, at the shallow end, it's 1.3 meters at the shallow end, and 4 meters at the deep end, as shown. Okay, so 1.3 at the shallow, and 4 meters at the deep end. So if 1.3 is the shallow end, that means, and 4 is the total, that means 1.3 minus 4 is 2.7, right?
Mm-hmm.
So this part here, from here to here is 2.7, does that make sense? Divided, shallow end is
wait.
1.3, the total depth is 4, so the difference would be like this. Okay.
Wait, shouldn't the camera?
Okay, and it says, find the angle of depression in degrees of the bottom of the pool. Okay, the bottom of the pool. So here's the deal, here is another triangle, yes? Okay, we got two triangles going on. We wanna figure out what the, angle of depression is that correct? It's the angle of depression, so we wanna figure out the angle right here. Okay, we wanna figure out what is the angle of depression, meaning what angle does this water take a, difference in? So the lowest part is 1.3, the highest part is 4, so what is that angle that we are diving down in at? So like the further you walk into the pool, the deeper it gets, yes?
Yeah.
Okay, what angle are you going down at? What angle are you walking down at? That's what it's asking. Does that make sense, Tyler?
I'm trying to figure out the
Okay,
problem.
so we're trying to figure out this angle right here, this angle of depression. How can I solve for that theta, for that angle?
You have to do,
Theta is always an angle.
what's it, opposite over, right, nope, that ain't
Cosine.
Look, what do you have?
it. You gotta,
If I go through this, I have what?
opposite,
And
adjacent.
So-
Break
tangent.
the whole camera.
Tangent equals opposite
It over adjacent.
What is my opposite?
Your opposite is
2.7, good, it's just the 2.7. So I have tangent equals 2.7, what's my adjacent?
20.
20, okay, so what is 2.7 over 20, what is tangent 2.7 over 20?
Hold up, y'all, hold up.
Whoa.
1.35.
Hold on.
Okay, never mind.
So you have to do 20 tangent and then divide it by
No, you have to just just reduce 2.7 and over 20.
0.135.
0.135, so just divide that part out first.
Oh,
Oh,
Is it
Now,
weird? I'm kinda excited.
Because we're doing angle, yes, because you're doing angle, how do you find an angle?
I like when they do it.
How do you find an angle?
Oh, wait.
You have to use what?
you have to use,
No. You're still using tangent because we're dealing, Corey, you might wanna pay attention.
Yeah. Or, yeah.
Listen, when you find a side line, you use sine, cosine, and tangent. When you find an angle, you have to use what button?
the regression.
Degree. Right.
How about this?
It's a snow globe.
EMF.
Swimming inside.
The inverse. Remember, if you're finding an angle, it's the inverse. So do second, and then tangent, and then do that 1.35, and what do you get? 7.7 if I round, yes? So it's inverse to 7.7 degrees,
Well, we can tell me.
7.7 degrees.
because you have to use the inverse of tangent. When you're finding angles, you use the inverse. When you're finding side lengths, you use regular tangent, sine, and cosine. Inverse sine, inverse cosine, inverse tangent for that. Honey, your mode has to
Well,
be
first
in
one.
degrees, not radians.
Yes, Lord. You tell her. Yes, Lord.
Okay,
So,
those are the things you are working on tonight. Okay?
Picture time.
Can I send you a